As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-through or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. Star Talk. Neil Degrasse Tyson here, your personal astrophysicist. This is Cosmic Queries edition. Cosmic Conundrums.
Ooh.
Would sound like we couldn't fit them together into one category.
Right.
So we just
Put them all together. Right. Better known as hodgepodge.
Hodgepodge. Chuck
Cosmic-
Nice in the house. We
There
are
we go.
in the coronavirus.
Yes, we are.
All right.
Well, of course, we always have our different inquiries as gleaned from all over the internet. And as usual, we start
Wait. We're not bringing in another expert, so this means I have to know all the answers.
Yes, you do.
Okay, fine.
As like you don't anyway. So, but yeah, we always start with a Patreon patron because you guys give us money. Thank you, by the way. Thank you for your money.
Is there a nicer way to say that?
No, I just like being direct like that because
Okay,
it sounds
fine.
cool. You know, thank you for your money, which is what I used to want to say on every birthday.
And allow me to say that we're using the money to invent other incarnations of what it is we do.
Absolutely.
Which are all in themselves experiments that we test. We battle test them, see if they work, refine them, and that takes money that we're not otherwise getting from sponsors.
No, exactly.
That's my point.
I mean,
it keeps us vibrant.
It does.
Yeah.
And the Patreon people don't even know there's stuff that we've done because of you.
Yeah.
You know, which is cool. All right, let's go to Stacy Brown, who's our first Patreon patron, and she says, Dr. Tyson, if you were captain of the Starship Enterprise, where would you go first and why? And of course, we have to suspend disbelief and say that warp is real. So traveling at beyond the speed of light is now a capability. So now that gives you the option to leave this galaxy, go anywhere you want in the observable universe.
I would stick in my own galaxy.
Oh.
Because there's not enough we know about it. So let me just know my backyard first.
Alrighty.
All right. And then I would take a tour around the galaxy.
Okay.
Just around the hood.
Right.
All right.
Once around the block, James.
Once around the block. If left to the solar system's own motion, that takes about 200 million years for one trip.
Cool.
And so, that's still fast given the scale of all of this. But the sun and all the planets and all the comets and all the asteroids and everybody is all moving around the galaxy together.
Nice.
Okay. Now there's something happened on the internet recently. Of course, if we are going around the sun,
correct,
and the entire system is orbiting the galaxy,
right,
it means we don't complete a closed orbit around the sun. All orbits are corkscrews.
Right, because the galaxy is also moving.
Well, the solar system, is moving
within
the right. So if you followed the path, so there was all this attention given to someone showing the video of this and saying, "Oh, this is a new theory of the solar system. Oh my gosh, did the experts know this?" So it's like, people, this is just two motions simultaneously.
Right.
Okay. If you do this, you orbit.
Right.
If you go that way, it's a straight line.
Right.
If you do this and that, you get a helix.
Corkscrew.
Yeah, a corkscrew.
Right.
So
it's like when you drop a ball on a plane.
Oh yeah.
Yeah.
Well, it goes straight down to you.
Straight down
but if I'm watching you, the ball actually went forward at 500 miles an hour.
Exactly.
Yeah.
It's cool.
But so did you.
Right.
So it just went straight down to you.
Exactly.
Right.
So that's cool.
Yeah, wait. So I would do that. That's just but then I'd go straight to the center and observe the supermassive black hole dining upon stars that have come too close.
Nice.
That's what I would do.
All right. Gonna watch the galaxy have a snack. Okay. There you go, Stacy. All right, let's go to another Patreon. Tony Mirabella Wants to
Cool
know
name.
this. That is a cool name.
Tony
right?
Mirabella.
He does sound like a Vegas act, right? That's kind of cool.
Tonight only.
That's
Tony
right.
Mirabella.
Welcome to the beautiful downtown Stardust Lounge here in Vegas. Ladies and gentlemen, it is my pleasure to bring to you the one, the only, Tony
Mirabella!
Yeah.
And he's singing before he comes out.
Yeah, well, that talk has.
He's singing off stage first, and he comes on.
Exactly. All right. That was so stupid. Okay. He says, what do you think unlocking the secrets of dark matter could do for us scientifically? Would it lead us to being able to harness it? Wow, those are two really big questions.
How old is he? Is he some kid in a basement trying to
figure something out?
A future superhero nemesis in the making.
He's making his own little universe or something. Can we harness this?
We have no idea what dark matter is. I have my own preferences, but my preferences don't matter. What matters is what experiments are active and in progress. And right now, the going thinking is that it is a category of particle that simply doesn't interact with us electromagnetically. So electromagnetism is like light and magnetism and all the things that make atoms stick together as molecules. So you are held together by electromagnetic forces.
Mm-hmm.
All right. That's why.
And therapy twice a week.
No, I don't know if that's holding you together, but physically. Yeah. Emotionally is another thing.
Oh, okay.
Okay. I don't know what's holding you again emotionally.
Right.
Physically, you're held together by electromagnetic forces. This would be a category of particles that does not interact with our electromagnetic forces, which means they just pass right on through like you're not even there.
Right.
But
so how do you observe something like that?
Gravitationally. Okay, so we have the only reason why we know there's dark matter here is because, well, we have some galaxies, but add up all the matter in those galaxies, it doesn't account for what's going on in this part of the neighborhood. Because you see galaxies from behind whose light gets lensed according to Einstein's general relativity. And you can ask, how much mass does it take? How much gravity does it take to lens by that amount? And you come up with a number way bigger than simply counting the galaxies that are there.
Right.
Something else is happening. So we call it dark matter because we don't know what else to call it. It's, like I said, I've said many times, it's really dark gravity.
Right.
It's literally dark gravity.
Right.
We don't know if it's matter. The folks betting on it think it is matter, and there's a new kind of particle that we have yet to isolate. That's all. That's what that is. So, if we do isolate it, what would you do with it? You put it in your hand. No, it'll pass right through your hand because it doesn't interact with your hand. All right. So I don't know how you would contain it.
How do you contain it?
You would need a dark matter box.
Right.
Well, who's going to make the dark matter box? I mean, it's a philosophical problem.
It really is.
If there's a thing that passes right through you,
how do you contain it? The thing that passes through everything.
Everything.
So everything it passes through, you need to find something
that can hold the thing in.
Right.
Correct.
There you go.
You need something that interacts not only with our forces, but also with its forces.
Exactly.
That could be yet another frontier of discovery in the universe.
What is that intermediary thing?
If you were that civilization,
right,
you'd be badass. Oh my gosh. You control not only all the universe that we know about, but the rest of the universe that's influenced by dark matter. You'd be able to grab it, make dark matter planets out of it, if you can make it stick to itself. So yeah, that would be a powerful posture to purvey.
All right, so now take that and dark energy.
Is that also in the question?
Oh no, that was
no, it's not in the question. I answered Vegas Act.
You answered Tony Mirabella's question. I'll move on.
All right.
Maybe it'll come up in a different question. You're like, don't push it, bro. All right, here we go. Eduardo Munoz from Facebook says, Eduardo.
He's selling.
Hello, my name is Eduardo. Perhaps you know my good friend, Kitty Soft Buzz.
Who was that in Shrek?
That's what's his name? Antonio Banderas.
Antonio
That's
Banderas.
Puss in Boots.
Puss in Boots in Shrek. That was really good.
Yeah, I love it. Okay.
Mhm.
So Eduardo says, can you explain to us in mortal language?
By the way, he's from Brooklyn. He's named Eddie. By the way.
Yeah, that'd be funny.
You are fantasizing about Shrek 4 or whatever.
And he's sitting in Brooklyn. He's in Park Slope somebody going, yo, Eddie. All right. Can you explain to us in mortal language how the boson gives mass to matter?
Oh.
So how does Higgs work? The Higgs boson. How does it give
Yeah.
mass? How does it give mass?
Yeah. So let me attempt this.
Yeah,
okay.
That's a lot.
So you need to think of mass not as mass in the traditional sense, and not in this explanation. Think of it as inertia. Okay? So inertia in common parlance is the tendency of something to want to stay in motion.
Right.
But it's also the opposite of that, or the inverse of that. It's the tendency of something to not want to move.
Right, to stay at rest.
Okay?
Right.
Okay. So inertia is whatever the thing's doing,
It wants
that's
to do
what
that.
it wants to keep doing
That's
that.
it.
All right? That's it. Okay.
Inertia.
Okay.
Lazy.
So you can measure the mass of something by finding a way to measure the inertia that it wields.
Gotcha.
Okay, so now watch. Let's go to Hollywood.
All right.
And we're going to a Hollywood party.
Okay. I'm already uncomfortable.
And
I used to have a drug problem. No,
pick-
go ahead.
pick an actor who like no one has heard of that you know of.
Chuck Nice.
Okay. You act in a couple of things.
have.
What have you been in?
Oh, please, let's not embarrass
No, tell me
me.
one. Tell me one.
I just did Kevin Can Wait.
Kevin Can Wait, the TV
the TV
series.
show.
Okay.
And it got canceled.
Okay.
I did an episode and they were like, well, this is over.
This will never work. He broke it.
There we go. But anyway, go ahead.
Okay. So Chuck Nice walks into a party
Right.
in Hollywood.
And
And the bar is on the opposite side of the floor.
okay.
Okay? It's a crowded party.
All right.
You want a drink.
Okay.
You walk straight to the bar.
Absolutely.
You'll get there in 10 seconds.
Of course I will.
Okay. Beyonce walks in.
Okay.
She wants to go to the bar.
Thank God, because I'm already there.
She wants to go to the bar.
Right.
But what happens? She begins to accrete
Beyonce! Oh my God,
people.
Beyonce!
That's correct. So
Beyonce, oh my God!
she can't get to the bar in 10 seconds.
No way.
She has a very high famous person mass because everyone wants to be around her. And so her posse moves slowly through the room.
Gotcha.
And if you move fast, you have low party inertia. She moves slow. She has high party inertia, a resistance to going fast. Okay? So you have low resistance to going fast. You just walked right across the thing.
Right.
So,
Or no resistance.
or no
Yeah,
resistance.
yeah, that
Exactly.
would be me.
Yeah, people, in fact,
Right.
if
Matter
you're
of
funky
fact,
smelling, they're parked away.
I was going
you
to
get
say,
there faster.
If it's me, I go straight past the bar, out the back
Out
door,
the back door.
because that's how much they actually want me at the party. Okay, but go ahead.
All right.
So this is making sense so far.
So there's, think of it as the party field. Okay?
Okay.
The party field is giving mass to the particles moving through it.
Gotcha.
Okay? That party field is like
right, because those are
like
the
a
party,
Higgs field.
Those are the party goers. Right.
The Higgs field is
Right.
like, they're like the party goers in Los Angeles.
In Los Angeles.
Okay?
Right.
So you got that? So if you, the more famous you are, the slower you can move through a crowd because everybody wants a piece of you.
Right.
All right. So in that way, Beyonce has a very high party mass. You have a very low party mass.
Correct.
And you get everybody else in between.
Gotcha.
So that's kind of what the Higgs field is doing. It is the resistance to movement of the particles that pass through it.
God, first of all, it's just a great picture. You know,
Because we can all imagine that,
yeah,
right?
That's a great depiction.
Yeah.
And that is fascinating. Like, who thought of that?
I don't know. I might have heard it somewhere. I don't remember.
That's awesome.
Yeah. Yeah.
I mean, that's probably the best way you're ever going to understand.
I think so. I think so. Yeah.
Yeah, that's great. That is really, really good.
Oh, and one other little thing that we learned from Jana. Okay.
Yes.
Friend of Star Talk.
Jan 11.
Jan 11. That grants particles its mass, but it's not most of the mass of the universe. Most of the mass in atoms comes from the force fields inside the atom, not from the particles themselves.
Wow.
Binding energy of the atoms. So yes, it gives mass to quarks and electrons and this sort of thing. Yes, but the total mass of everything in the universe is not represented by the Higgs field. It's just the particles within that are out there.
Gotcha.
Okay, so just a little detail.
Just a detail.
I got straightened out on that by Jaina.
That's
Okay.
cool, man. Well, that's all really good stuff. Man, Eduardo, I hope that cleared some things up.
Cleared. We're going to take a quick break. When we
Claro
come back,
que sí.
more. Okay, well, you got to take us out in that voice. Go.
Stay tuned. More Star Talk, Cosmic Conundrums, when we return.
Live with luxury. Live with power in the all-new Toyota Sienna Platinum. The all-new Toyota Sienna is an all-hybrid powertrain with upgraded style and available features like all-wheel drive, a second-row captain's chairs with ottoman, and a 1,500-watt capable power outlet. Live the Sienna life. Or live with style and live bolder in the all-new Toyota Sienna XSE. With upgraded interior and exterior styling and available features like 20-inch dark wheels, an HD entertainment center, and hands-free door and liftgate. Whichever you choose, live the Sienna life. Toyota. Let's go places.
We're back. Star Talk. Sorry, did I do it? Sorry, I don't have it. I don't have the what should we call that?
That is an accent.
I guess so. I
That's all.
don't have the accent.
Mm-hmm.
All right. Keep going. Cosmic Conundrums.
Here we are. All right, here we go. Here we go. Jenny Totten wants to know this. She's coming to us from Facebook. Hey, Neil, does time move faster at the expanding edge of the universe and slower at the center? Now, in there are some assumptions that I don't know. You might have to talk to, first of all, the center part, and I don't know. However, I love the question in terms of the expanding edge.
Okay, here's something interesting.
Mhm.
Might not be what you were thinking.
All right.
If you're moving away from me
Right.
in an expanding universe,
Right.
and you have a clock that's ticking seconds, okay? If I watch that clock, consecutive seconds that I observe will come to me more and more delayed,
Right.
okay? So when I observe you, it will look like you have slowed down.
Right.
But as far as you're concerned, you're just running
I'm
a
just running a
stopwatch.
stopwatch.
That's
Right.
right.
That's
That's
it.
right. So when she talked about the expanding edge, if you're going to watch that edge,
Mm-hmm.
you will see things slow down in that place,
Right.
okay? But it's not an actual edge.
Right.
It's not a physical edge. It's just a horizon where that's all that is. If you go to that edge, now you're in the middle of a new horizon that is itself whatever distance away it would need to be
Mm-hmm.
if you did the math on that.
Right.
So the way to answer that is if you want to make any of that true, it's the opposite of what she said.
Gotcha.
You'd be observing objects evolve more slowly on the edge, the expanding edge, and you relative to you.
Right.
Yeah.
Gotcha. Okay. That's pretty cool, actually.
Yeah.
That's pretty dope, I gotta say. I
Mhm.
like that. All right, let's go to Virgil Hayward. And Virgil says, it's pretty cool, man. I gotta tell you, these people, they're into this
We
stuff.
got good people.
We do.
We got good people.
Damn. He says, is there any theoretical way to destroy a black hole?
Oh, yeah.
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 Cool.
You just wait around till it evaporates.
Oh, man. Gave me the
I'm
okie
sorry.
doke. That's the okie doke.
I'm sorry. It's an answer. It's the answer. You just wait around. Small ones evaporate faster.
Right.
Big ones, like the ones in the centers of galaxies, they might take, I don't know.
A trillion years.
Much longer than that.
What?
Oh, yeah.
Google years?
Yeah, Google years.
Oh
I'll give it a
my
Google.
God.
By the way, Google people is an actual number.
Yeah.
And it was a number before it was the name of a corporation. Okay.
Yeah.
And it's spelled differently, Googol,
Right.
Google.
Well, they
100
actually
years.
misspelled it.
Yeah, they misspelled it for the company.
Right.
So Google years is a 1 followed by 100 zeros. Then you can evaporate the seriously large, massive black holes in the centers of galaxies. And yeah, then in that future, it'll be a universe with nothing because all the stars would have died.
Mhm.
The proton would have decayed.
Right.
So the very foundations of matter would have broken up into fundamental particles.
Right.
And
really all you have is particles.
particles.
That's
exactly.
all you have.
That's all you have.
Right.
The fundamental particles of the cosmos. So the universe will end not with a bang, but with a whimper.
Cool.
And not in fire, but in ice.
Cool. Literally.
Cosmic conundrum. Cool. Literally. Cool.
Yeah.
That reminds me, there's a line in Back to the Future, the second one,
Right.
where I think it's the second. No, the first. Whichever one it is, Marty keeps saying, "Oh, that's heavy. Oh, that's heavy." And Doc says, "Why do you keep saying it's," because it's 1955, right?
Okay.
Why do you keep saying it's heavy? Is something wrong with Earth gravity in the future? That's exactly what I would have asked if I were
cute.
Doc.
I like that.
Yeah.
All right.
That's Back to the Future 1.
So, yeah, there you have it, Virgil. It's wait is your answer.
We'll just wait around.
You gotta wait, bro.
Yeah. That's why we don't know any way to undo the black hole.
Right. The theoretical way to destroy it is time. There
Yes.
you go.
Uh-huh.
All right, here we go. Lee C. Schneider
Okay.
from Facebook says, which is more likely, extraterrestrial contact celestially or interdimensionally?
Oh, definitely physically. Dimensions. No.
No,
I want it to be true.
you do.
Oh, yes. But access to higher dimensions? Come on now.
Right.
I think we even did a thing on
Yes, we did.
going to the fourth
right.
dimension
That's
from the
right.
3 dimensions, 2 dimensions.
With the sphere that drops through a piece of paper.
Exactly.
Which
And
is just a
You lo-
painterly beautiful.
you love that analogy.
I do because it makes things
Well, let me
so
describe it for people.
easy.
So if you have a intersection of dimensions, the consequences can be extraordinary.
Yes.
So if we live inside a sheet of paper and a 3-dimensional being says, "I've got this sphere," and they don't even know what a sphere is, all they have are circles. Ha ha ha, right? So a circle is a sphere in 2 dimensions,
Mm-hmm.
or a sphere is a circle in 3 dimensions. So you can say it either way.
Right.
So if I'm a mighty 3-dimensional creature and I take a sphere, a hollow sphere, and I pass it through your universe,
Right. My paper universe.
how would you describe this? You say, "Oh, there's a dot." Where did that dot come from?
Right.
It's mysterious.
Right.
Then the dot becomes a circle.
Right.
Now, you only know it's hollow in the inside because I have to open up a portal so you can look in. Otherwise, it's just you wouldn't know it's hollow.
Right.
But anyhow, so it's a circle. And what happens to the circle? It grows.
Mm.
Until what size?
Until it's the diameter of the
Until the
sphere.
full diameter of the sphere.
Right.
And then what happens?
And then it would shrink.
Shrink down and then becomes a point and then disappears completely. And you have to explain that to your friends.
Right. That is so cool.
So imagine a 4-dimensional thing passing through our universe.
Right.
That would be, how would you even describe? You'd see a cube show up in the middle of nowhere and then disappear,
Right.
right? That would be the 3-dimensional slice of the 4-dimensional hypercube passing through our 3-dimensional world.
Wow.
So in other words, the 2-dimensional slice of the sphere is a circle
Right.
passing through your paper world.
Right.
The 3-dimensional slice through a 4-dimensional hypercube is just a cube.
Right.
So the cube will start small, get bigger, and then shrink
That's
down
right.
again, disappear.
Damn. Wow.
I know. No, dimensions are cool. So
That's
I don't
cool.
know how to access another dimension. I wouldn't even know where to begin. So I will bet that we will contact extraterrestrials
But-
before we know how to go in and out of higher dimensions.
Right. But the idea would be that, so here's what I want to tack onto this though. They would know how to observe us, but how would we ever be able to observe
If
them
they
though?
came, if they're higher dimensions,
Yes,
they,
they're the higher
they
dimension.
could observe us and we would not even know they were
Never
there.
even know they were there.
Correct.
So then, okay. And so then what we would only be able to observe is what they are able to put into our
No, not to put into it,
Not-
to pass
pass
through
through.
it.
Not
Yes.
put in, but pass through
Correct.
our reality.
Yes. I guess they could put it in our reality, but it would be so their reality is so much richer. They'd want to just pass it through.
Right.
It's like, so let me give the paper people something to play with and just draw a circle. That,
Right, exactly.
Right,
That's not going to do much.
Yeah, right.
So we would observe that. We would never be able to observe their universe. Period.
Unless we had access out of our dimensions to their dimension. That's correct.
Wow.
Now, here's something interesting. Ready?
Go ahead.
If you're a two-dimensional being,
Right.
and you have skin, so you draw the skin,
Mm-hmm.
well, you have an insides.
Okay.
We three-dimensional beings would be able to see inside their bodies. The heart, the lungs, the mouth, the eyes, everything.
Right.
But they would not be able to because they can only see in the paper, and they would just see the outer skin, which is just a line.
Right.
What that means is a four-dimensional person can see every one of our organs at all times.
I feel so naked. I feel violated.
They can see inside your organs.
That's cool.
So surgery, the future of surgery could be four-dimensional surgery, where they come at you from a fourth dimension and never have to cut you open. Think about that.
I like it.
That's a sci-fi story right there.
Got to tell you, never going to happen in America. Not with this healthcare. That's all I can say. Yo, that is so cool.
Yeah,
hey, Lee, thanks so much for that question, man.
Mm-hmm.
That's very, very cool. Let's go with
Time for a couple more questions.
Okay, Mario Fierera.
Mario
Fierera says, do you think it's possible we'll find complex organisms like fish in the liquid water masses in the planets and moons of, he says, our solar system?
Yeah. Okay, so first, a fish is a way complex organism, right? Generally, when biologists speak of complex organisms, they're not talking about fish.
Right.
They're talking about multicellular creatures that might have some appendages. They might have, like at the Cambrian explosion of life, when was that, 450, 500 million years ago,
Right.
we went from single-celled creatures rapidly, when the conditions changed on Earth, to multicellular life. And that multicellular life had like limbs and eyes and it had features
Okay.
that you could talk about and point to.
Right.
Generally, we call that complex life.
Complex.
Okay, and then you want
So
to.
how about it's a single cell organism, but it has propulsion, like
Well,
cilia or like,
you mean a way to move
a
around?
way to move
No,
around.
that'd still be simple.
That's
If
still-
it's single cell,
single
that's
cell is
simple.
still not. It's
Correct.
still simple. Okay.
Correct.
Even if it's moving or not.
even it can do all that. But we're talking about I got legs
Right.
and I got eyeballs
Right.
and I got a nose and ears, that
Right.
sort of thing.
That thing.
That's
Okay.
complex.
Features, as you said.
So
There
the
you go.
question was, will we find something? Okay, I want to find life in the oceans beneath the frozen surfaces of the moons of Jupiter and Saturn. And I want there to be life there.
Mm-hmm.
But if there isn't, okay, I'll deal. I'll recover.
Right.
But if there is life, it'll be something that swims. It'll be something and think of all the things in the ocean that swim that are not fish.
That's so true.
Well, swims or that is alive, like coral.
Right.
You have shellfish.
Right.
I mean, swimming fish,
Yeah,
right?
exactly.
So who else do we have? We have Ariel is there.
Sebastian.
How can I forget Sebastian?
Right.
Yeah, the hermit crab.
Right.
No, the hermit crab. He's got a Jamaican accent.
Why you do this to your father? Ariel. Your father, he love you so much. Anyway.
So you got Ariel, Sebastian. You've got what else? You've got sponges.
Sponges.
Yeah, I mean, just you got
clams and oysters.
You got
and
SpongeBob is down there.
starfish.
Yes,
Right.
SpongeBob.
SpongeBob.
Who's the starfish in SpongeBob?
Patrick.
Patrick, of course.
Correct.
I was confused with Mr. Woodward.
Squidward.
Squidward.
You know what? I just realized I know too much about SpongeBob. That was too easy for me.
You didn't even.
I
let me
didn't
think
even
about
bat
it.
an eye.
You did.
That was way too easy for me, man. That should not have
That
happened.
should not happen.
You know, we doing a show about astrophysics here, and who's
Just
SpongeBob?
laying out the SpongeBob characters.
Patrick, and then there's Mr. Crab, and of course there's Squidward, and oh God,
And who's the squirrel? Sandy.
Sandy.
Of course,
That's
of course.
right. Thank you.
Yeah. So Anyhow, where was I? Where the hell was it? So
You're saying if the life is going to be there, it's going to have features, and you want that.
It's like it could be. I mean, think about it. It'll be at least as exotic as the range of creatures that are exotic in our own ocean. Right. Exactly.
And the funny thing is, the deeper you go in our ocean, the more exotic the life becomes.
Yeah. Well, the less you've seen it before. Less they've seen you. You look exotic to them too. We got to take a break.
Thank you.
When we come back, that was not a compliment, Chuck. More Cosmic Queries, Cosmic Conundrums when we come back.
Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Daniel R. Scott and Sand McDowell. Thank you so much, guys, for your help. Without you, we couldn't make this show. And for those of you who are listening who would like your very own Patreon shout out, go to patreon.com/StarTalkRadio and support us. We'll love you for it.
We're back. Cosmic Queries, Cosmic Conundrums. Very nice. Mm-hmm. Chuck.
Yes, sir.
Bring them on.
All right, let's just jump right back into this. Mm-hmm. This is Ross.
These are good questions so far.
These are very good questions so far. Ross Nippled says,
just one thing about the previous segment's question.
Yeah.
Asking about what kind of life we might find, if we find life in the oceans and things. It's not only if there's water there.
Right.
Okay. I just want to get thermodynamic on you.
Okay.
Okay.
Go for it.
All right. As far as we know, whatever life is, it will require metabolism.
Okay.
Right? It'll have to process energy in some way.
Okay.
For it to process energy, in its environment, there has to be a place that has more energy than in another place.
Mm-hmm.
Right. So that there's energy flow. Okay?
Yes, exactly. Like our sun.
If the entire ocean were exactly the same temperature and there were no water currents and there was no source of energy, we don't know how life could come to be or exist or even thrive.
So life does not happen without a transference of energy.
Correct. And technically you'd call that an energy gradient.
Okay.
Okay?
Right. Gotcha.
So that's what you need.
All right.
And so under there's sources of energy from like the gravitational stress from Jupiter and from Saturn and other moons on those moons. And that pumps energy like deep in the center. And so
wait.
If it's hotter in the center than in the edge, then we're good.
So you mean the gravitational forces of the planet that this moon is orbiting?
Yes.
The tidal forces causes an undulation.
Yes.
That creates energy heat.
Yes.
Like when you bend a paperclip back and forth.
A better example would be when they say, if you're going to play racquetball, let's warm up the ball. And what are you doing? You hit the ball. You squeeze it and it pops back out. Every time you do
deformation and a
restoration. And every time you do that, you're pumping energy into the ball from your racket. Yeah, that's what's going on to those moons right now.
All right, that's
dope.
That's really
dope. And the hottest moon in the solar system is called Io, and it's closest moon to Jupiter.
Right.
And it's feeling this ferociously, and it's got the most ferocious volcanoes that ever were. Because it's hot in the middle, the stuff has got to get out, and it's hurling.
And
every day.
that is basically from gravity. That's all.
Gravity stress.
Gravity stress.
Yes.
Stress of gravity.
Pumping it. And it's, by the way, it's outside of the Goldilocks zone.
Right.
So we used to think, you need the sun and it's got to be just right. And no, you just need energy.
Right.
People. All right. Wow. There you go. Okay.
Damn.
All right,
God, I just love science. It's so good. That is just so. All right. Roy Luckett from Facebook says this.
Roy, what?
Luckett.
Luckett. That's a word?
Yeah,
that's a name?
That's a name, man.
All right, Roy.
Roy says, hey, Neil.
Roy Luckett. That's a cowboy name. Hey, I'm Roy Luckett.
How y'all doing?
I'm Roy Luckett.
Welcome to the Grand Ole Opry. I'm Roy Luckett.
Come on by for the rodeo.
All right. No. Roy Luckett says this. Hey, Neil, let's talk about low orbit.
Nice.
And that's all he says.
Okay. So, is that all?
That's it.
Oh.
That's why I wanted to read it, because Who writes that question?
That's cool. That Roy Luckett said
Yeah,
that.
Lord Roy Luckett. And you know what that does?
He's
sound-
kicking back with a beer,
I was
and
gonna
he
say,
wants it. Talk to me.
There you
Bring it
go.
on. Right.
That's right.
All right. So, ooh, how deep into this rabbit hole do you want to go?
I don't know, man.
All right, you ready?
Low orbit.
Low, you ready?
Go.
I don't think you're ready.
All right.
Are you ready?
I'm about as ready as I'm ever going to be.
As ready as you think you can be for what I'm about to tell you?
That's right.
All right. So, does it make sense to you that people, this is like inside baseball here, okay?
Right.
Just be ready for this.
Okay.
Does it make sense to you that on Earth's equator, people weigh a little less than people anywhere else on Earth because of the centrifugal force of Earth's rotation?
Okay.
Okay, the equator is moving the fastest.
Right.
Basically 1,000 miles an hour.
Okay.
Because we have 25,000 miles in the circumference. And how long does it take Earth to rotate once?
24 hours.
About 24 hours. So you divide those,
All right.
it's about 1,000 miles
Okay.
in an hour. About.
All right.
Okay? All right. If you had a different latitude, the circle you take in 24 hours is smaller. Right on down to the pole, where Santa's got no circle at all. He's just pirouetting. Okay?
Very nice.
All right. So, yes, we're rotating as a solid object, but the folks moving the fastest are right on the equator. And I forgot I did the calculation once. They weigh about, 4 ounces, about a quarter of a pound less.
That's a lot.
Yeah, no, it's a lot. No, it's measurable. It's measurable with a household scale.
Yeah, I was going to say, I
Okay.
thought you were going to come up with some like,
micro
yeah,
something.
like,
No, it's real. It's real.
Whoa.
Okay.
Okay, that's cool.
And-
That's cool.
all
So
right.
far, so good.
So let's spin Earth faster.
All right.
They'll weigh even less.
Okay.
Poor Santa, his weight doesn't change at all.
Right. Well, because first of all, he's fat.
No, stop.
Let's be honest. The
No,
brother-
he's just pirouetting.
of course. yeah,
So there's
there's
no
nothing
centrifugal
happening.
force on the pole.
Right.
All right. So that's what Taylor's doing. Now you weigh a pound less or kilogram less, whatever is your favorite unit. We just keep doing this. And you can ask yourself, at what speed must I rotate Earth so that you don't weigh anything? You'll just float there on the equator. That's an askable question, isn't it?
It is.
If I'm spinning you up and you're weighing less and less and less,
right.
you know what speed that is?
What?
You rotate the Earth once every 90 minutes.
Every night, instead of 24 hours,
Yes.
it's an hour and a half.
An hour and a half.
And everything on Earth would just
No.
fly out into space.
Everything
No.
on the equator.
Everything on the equator, because that's right.
Everything on the
Because the other
equator.
stuff doesn't weigh as much.
It's okay.
Right.
All right. The other stuff doesn't have as much centrifugal force.
Right.
All right. So,
I noticed. Go ahead. Keep
Okay,
going. Keep
so
going,
wait a
keep
minute.
Going, keep going.
so if I'm on the equator now and my feet aren't even touching the
I'm
ground,
just floating.
I'm just floating.
Right.
Yet somehow I'm staying with Earth
Right.
as you had always been, even up to that moment.
Correct.
Up to that moment, you're there. Now you just weigh 1 pound. You can jump high, but you're still rotating with Earth. You rotate Earth a little extra. Now you're just floating.
Wait,
I just
let-
described for you orbit.
Oh.
Low Earth orbit.
I forgot that's where
That's
we were
where we're
with this.
going.
That is
Do you know how long it takes the space station to orbit the Earth? 90 minutes.
so that. Oh wow, that is cool, man. I dig it.
Is
That's
that good?
It. That's it.
Is that good?
That makes sense.
Is that good?
That's good.
That's an orbit.
I love it.
Okay. So low Earth orbit is now, of course, low Earth orbit in practice, you want to be above enough of the atmosphere so you're not, burning up through the atmosphere.
Of course,
So you want to be high enough. So that you go up 100 kilometers, about 60 miles, you're high enough above most of the atmosphere so that you can now orbit the Earth faster than the Earth would take you.
Mhm.
And you complete one orbit in 90 minutes. If you're right exactly above Earth's surface, it's actually 88 minutes. Okay.
Right.
88.
Right.
If you do the math,
All
it's
right.
88 minutes.
Yeah.
You go up to where the space station is about 90 minutes.
Gotcha.
Okay. All of that's low Earth orbit. LEO, we call it
Leo.
affectionately.
Low Earth orbit.
Yeah. You go a little higher up,
Right.
500 miles up, that kind of thing.
Mm-hmm.
You get to MEO,
Mm-hmm.
medium Earth, middle Earth orbit.
Okay.
Not middle Earth,
Right.
but middle Earth
Middle
orbit.
Earth orbit.
Middle, okay.
Right.
And there you'll find the GPS satellites.
Okay.
All right. So they'll do an orbit. It'll take longer than an hour and a half, but slower than 24 hours.
Okay.
Okay. Then you go a little higher. You get GEO. geosynchronous orbits. So these are orbits where, now, you can do the opposite and say, if I go farther away, I can stay in orbit with a lower and lower speed, okay? And here's Earth turning beneath my feet. Is there a distance where I can orbit exactly with the rotation of the Earth so that I take one orbit in 24 hours? Yes, there is. It's 23,000 miles up, and it's called geosynchronous orbit.
And there's the synchronicity.
There's the synchronicity.
Wow.
So you launch that satellite, it just hovers overhead.
That's very cool.
And if you park between Europe and the United States, you can beam signals up to it, and you can talk to beyond the curvature of the Earth.
That's it.
Elon Musk wants to launch constellations of satellites so that you don't have to beam out to 23,000 miles. You know why? Because if you beam a light signal 23,000 miles, that's far enough away that the round trip, you notice that in telecommunications. It's a lag.
There's a lag.
It's a lag. You'll notice it. And sometimes you'll see it in a broadcast or even sometimes you've been on a phone and there was a lag. That's probably hitting a geosynchronous. So communication, you want the satellites to be lower.
Right.
But if it's lower, you're not always in view of it.
Right.
Because its orbit's out of your zone. It doesn't stay with you. So now, if once this goes out, you want another one coming in right behind it.
Right.
That's why Elon is launching hundreds of satellites so that everyone has fast internet and with no lag.
Cool.
Yeah.
Well, thank you, Elon. And thank you, Roy Luckett.
Roy Luckett.
Oh, damn, boy, I didn't know that was such a good question.
Leo, right there. That was Chuck. We got time for one more question. Make it a good one.
All right.
Or make it a bad one. We'll turn it into a good one.
Okay. Sean Farouk says this. If a faraway planet emits a light of low frequency and light of high frequency, which one of them will win the race and reach us first?
Oh. The speed of light in a vacuum does not discriminate by frequency.
Boom. There you go.
However, if it goes through a medium, it does.
Gotcha.
And it is because different frequencies move through media at different speeds that the colors manifest after it comes through.
Okay.
So if you put light through a prism and you put it in at the right angle, at the correct angle, the white light comes in and the prism says, blue, you're coming out first. Red, you're coming out last. I'm spread. And since it's spread, since they go through at different speeds, all the colors reveal themselves as they come out of the prism.
There you go. Separating in the process.
Yeah. So the prism is glass.
Right.
That will air will separate the colors.
Right.
Diamond does it the best. Is the most transparent. It's the densest transparent thing we know.
Okay.
So that'll do it the most.
Slows down the light
The most.
better than anything.
And it slows down light by to 40% of its vacuum speed.
Yeah, of course that makes sense. Which is when you look at a diamond and it refracts all the light.
Yeah,
and
the
you see
light
all
reflects
the pretty colors.
all the pretty colors.
Right.
That's what's going on. And it does it better than glass does.
Right.
That's why diamonds are diamonds and glass are glass. Right.
Don't tell my wife that.
Cubic zirconium gets you halfway there. I don't know. So different frequencies of light do travel at different speeds through a medium, and just to make that clear. And so now there is medium in space, like gas clouds. When light comes through there, you get this effect.
Right.
You get this effect, and you can get a time lag in an explosion if the explosion happens in multiple frequencies. You'll see it happen in one frequency before it does in another. And we have coordinated our telescopes to check for this.
Nice.
You have a radio telescope, a visible light telescope, a infrared telescope, and you can see phenomenon if it's coming through a medium that will differentially slow down the frequencies of light. No, it's very cool.
That is excellent.
Yeah. But in a vacuum,
So that's it. It's a tie.
the speed of light is the speed of light is the speed of light.
Speed of light. That's very cool.
Okay. Neil deGrasse Tyson and Chuck Nice signing off from the Coronaverse. Star Talk Cosmic Queries. Keep looking up.